Okay, so we're looking at the diaphragm wall over there. It actually, from there, if you can imagine it coming in from, let's take it from Kent. Comes through Kent, about a mile before the Thames Tunnel. It then starts to cut down, cutting straight underneath the Thames, which is directly in that direction. From there, it then surfaces on the Essex side and through that diaphragm wall, which will be the only wall with the CBM goes through the Hughes rebar, out. By the time it gets over to there where you can see the bridge, it will go through the bridge, out onto the other side, which is too soft and too marshy. From there on, it'll have a viaduct, and from that viaduct, that's a 5-kilometre viaduct, right through to Dagenham, past the Ford factory. After that, it starts to get into built-up areas through London, descend underneath, through Stratford Box, big contract, after Stratford, Barrington Road. Eventually, after 3 more contracts, it'll end up in St Pancras.
Okay, so this is the part of the cage built with the GFRP bars. As you can see, there are 3 rows level with 4 GFRP rods, 32mm diameter, in a bundle of 4. And any cage is 2 meters something wide and 1.2 meters thick. And the external loads generate tension both in this face and the other face. So we need to calculate how many GFRP rods we need according to the ACI code, and we find out that to support the external moment we need at least 3 rows of these bars. And the calculations are done in according to the service condition, because the service condition here was the governing factor. We need to limit the compressive strength in the concrete at service below 0.4 F'(C). This was the main reason in the big amount of rebars. Also we have stirrups, because this type of panel is subjected also to shear force. And the space of the stirrups is around 25 centimeters, and we have bundle of 2 rods, 16mm in diameter. Then the cage will lift up starting from one end to the bottom, and because the deformability of the system is larger than steel, you need to support with some temporary steel profile or steel frame, and then you can remove the steel frame and you can push down the entire cage under the ground. That's it. Ciao.
There, there's some guys who are
distributed, but since this is so elastic, it will work. Because if one is overloaded, then you get the effect.
And you try to lift up a little, no? After you have prepared...
No, we have it vertical. No, and then you have vertical.
No. After you have put this in place, have you tried to lift up?
Yes. No, not vertical, only horizontal.
All horizontal. Okay. This system is similar to the glass fiber, but they are put also in this top because to keep rigid.
Behind that, here material, mainly chalk, will fall down and will be pumped out. The chalk is in a slurry, in a wet slurry, pumped out here, somehow, and via two hoses. You can see in the section here, you have two hoses here in the tunnel. That's more behind. One is feeding this area with fresh slurry, and the other is taking
the other
with the chalk, this material. The TBM moves in that direction, and the tunnel remains.
And that's only 10 metres, about 10 metres.
That's
And you grind the back of the segment?
and then the segments. The next step is the TBM moves a little bit forward.
Yeah.
That means these segments are still the same. This moves to that segment, and they install the new segment.
Yeah.
New ring. That is the principle of the TBM. And behind this, I think that is called the TBM, and that is called the backup.
Yeah.
Behind the TBM you have the whole backup, that is the factory where everything is done, where the people do the work. Because you need to bring in, you see here, it's a small train coming in, bringing all the segments. And the train has to be, the segments have to be taken down, placed here, and with a segment feeder, you bring it here. Everything has to be done in a very good logistic. Because when the train comes in, you have to know what you're doing here. You have to know where this piece is laid, else you get a problem with it. Then you move forward and forward.
And the speed?
And the speed? The speed of the TBM is approximately 15 to 25 meter per day, 24-hour shift.